Hello everyone, this is Dr. Surya. So today we are going to see about the types of forces that is acting in a moving fluid plus the different dimensional numbers. So those two we are going to see in this video. So first there are 6 different types of forces that acts in the moving fluid. So the first force is going to be the inertia force. So inertia force is nothing but mass into acceleration of flowing fluid. So mass into acceleration of flowing fluid is called as inertia force. So how we can write this as we know that density is equal to mass by volume, right? So density is mass by volume. So if in that case, keep this as equation 1. So mass will be equal to density into volume. So density we denote it as rho and volume is V. So you can write it as rho V. So inertia force we are denoting it by Fi. So Fi is nothing but instead of mass I can write rho into V. So what is this acceleration? So acceleration is nothing but velocity by time taken. Right. So velocity by time taken. So what I am going to do is I am going to rearrange this equation. So how I am going to rearrange it is something like that. Fi is nothing but rho into, instead of volume I am writing it as rho V, right? So rho V is nothing but volume. So volume by time into velocity. So I am rewriting as simply, instead of velocity by time I am rewriting it as volume by time. Okay, what is volume per second? Anyone remember that? What is volume per second? We call it as discharge. So volume by time is nothing but discharge. So discharge is nothing but area into velocity. So I am writing that here. So volume per second is volume per second or volume per time is nothing but discharge, and discharge is nothing but area into velocity. Now I can substitute, instead of volume by time I can substitute area into velocity. So my inertia force will becomes rho into a into velocity. I am denoting it as V again, and there is one more velocity that is called V. So inertia force is nothing but rho a V square. Okay, now we'll go to the second force. Second force is viscous force. Second force is viscous force. We can denote it by Fv. Okay, so this viscous force is nothing but shear stress into area. Shear stress into area. That is shear stress because that causes due to viscosity and the surface area of the flow. Okay, so if supposing if viscosity is having an important role to play, then this viscous force will exist. So shear stress into area. So what is shear stress? Shear stress is nothing but tau into A. Shear stress we denote it by tau. So tau into A. So what is this tau actually? We already know the formula which you have learnt earlier, which is mu into du by dy into A. We can write like this, right? So what is this du by dy? So you might be remembering that in the first class when we take our viscosity chapter, or you might have just go back and see. So du by dy is nothing but velocity by length. So you can rewrite in this way. So which becomes mu into v by L into A. Okay, so my viscous force is nothing but mu V by L into A. So this is the second force, and we are going to move towards our third force, which is going to be a gravity force. So gravity force is denoted as Fg. So because of gravity, if it exists, then it is called as Fg. Again, it is going to be mass into acceleration due to gravity. Okay, So in the first one, if it is inertia force, that is mass into acceleration of flowing fluid. This is mass into acceleration due to gravity. Okay, as such mass we have from the density formula. So density is equal to mass by volume. So mass will be equal to density into volume. So I am going to substitute here density into volume. Acceleration due to gravity is nothing but g. Right, so this is how we have to do it up. And we know that what is volume. Volume is nothing but length into breadth into height, or in simple I can write it as volume as L cube. So I am writing this as volume. Instead of volume I am writing L into L into L, length into breadth into height, or L into L into L, which becomes L cube G. So what I am going to do is I am going to subdivide this L cube. So Fg is nothing but rho into L square L into G. So what is L squared? L squared is nothing but area. So Fg is equal to rho into A into L into G. So this is called as our gravity force. And the next fourth force is going to be the pressure force. So pressure force is we can denote it by Fp. So Fp is nothing but it's a product of pressure intensity into area. Pressure intensity into area. So which is P into A. Fp is nothing but P into A. Fifth force is going to be surface tension force. So this we can denote it by Fs. So surface tension force is nothing but surface tension per unit length. Surface tension per unit length into length. So generally we call surface tension as sigma. So which is sigma into L. So this is called as our surface tension force. And the last force will be our elastic force. Elastic force. So elastic force is nothing but elastic stress into area. Elastic stress into area. So we can write this as K into A. K into A. Or simply we can write it as instead of area I can put K into L square, and this is denoted by Fe. Elastic force is denoted by Fe. So these for a flowing fluid all the forces need not be present, but some of the forces will be present and it is not necessary that each and every force will be of equal magnitude. So some forces will dominate the other forces, and these dominating forces only it will govern the flow of the fluid. Okay, now we'll go to the dimensionless numbers. Dimension numbers are also called as non-dimensional parameters. So the main significance of this dimensional numbers is something like that. It is very useful to determine the flow characteristics of the fluid. Okay, and another thing is that these dimensional numbers it will reduce the number of variables that describe a system. So because of that what happens is that we can reduce the amount of experimental data which is required to make correlation of physical phenomena to scalable systems. So two things is that one is it is very helpful in determining the flow characteristics, and second one is that it will reduce the number of variables that is going to describe a system. So we are going to see a dimensional number one by one. So first number is going to be the Reynolds number. So Reynolds number is denoted by Re. Okay, so it is very simple. So Reynolds number, it's the ratio of inertia force by viscous force. Ratio of inertia force by viscous force is called as Reynolds number. So already we have defined what is inertia force, that is Fi, and viscous force is Fe. So we know that inertia force is rho a v square and viscous force is mu into v by L into A. So this A and A will get cancelled and you can cancel one B. So I'll be having this L, since it is in denominator, it will go to the numerator, rho L V by mu. Okay, so what is this actually mu by rho? Mu by rho is nothing but our kinematic viscosity mu. So Reynolds number is nothing but, either you can write rho VL by mu or VL by mu, kinematic viscosity, where mu is your kinematic viscosity. Okay, this is going to be the first number, and the second number is Fruit's number. It is denoted by Fe. So the Fruit's number is nothing but, it is the square root of ratio of inertia force by gravity force. So it is the ratio of inertia force by gravity force, square root of inertia force by gravity force. So we can put the square root, and inertia force, as we all know, it is nothing but rho a v square, and gravity force we have determined as rho a L G. So this a and rho will get cancelled. We will be having root of v squared by Lg. So Fe is nothing but v by root of Lg. So this is the formula for Fruit's number. Third force is going to be Eulers number. Eulers number, which we denote it as EU. So it is defined as the square root of ratio of inertia force divided by pressure force. Okay, so EU is nothing but, again, inertia force is rho a v square, and this is pressure force is P into A. So this A and A will get cancelled. So I am going to bring this rho to the denominator, which is root of v squared by P by rho. So EU is nothing but, I can take this, if I take the square root, it becomes v divided by root of P by rho. So this is the formula for our Eulers number. Fourth number is going to be Weber's number. So Weber's number, we denote it by We. So We is nothing but the square root of inertia force by surface tension force. So We is equal to inertia forces rho a v square and surface tension forces sigma into L. So instead of A, I can write it as L square v squared into sigma into L. So 1 L can get cancelled. So which becomes v squared by sigma by rho L. I am bringing those two terms in the numerator to denominator like this, and it becomes Weber number is equal to V by root of sigma by rho L. Okay, and the last number is going to be the Mach number, and it is denoted by M. It is also the square root of ratio between the inertia force and the elastic force. So M is nothing but rho a v square by K into A. Okay, so I can cancel this A off. Okay, So this becomes V squared by K by rho. So Mach number will be equal to V by root of K by rho. So these are the different dimensional numbers, and this is very helpful to determine the flow characteristics of the fluid. And there are also some model laws or similarity laws. So we'll try to solve in the next video about these, get to know about these model laws one by one, and we'll try to solve some problems in it. Thank you and happy learning.